Namaste, my name is Rishi. I am studying in Sri Venkateswara College of Engineering, Bangalore. I am studying in ISC department, 3rd sem. My USN is 1VE23 IS042. Today's topic we gonna cover is hash code in Java. Hash code in Java. This presentation dives into the essential concepts of hash code in Java, covering its functionally implementation and best practices. Introduction to hash code. Key value pairs. Hash code is a fundamental concept in computer science. It's often used to efficiently manage key value pairs within data structures like hash tables. Unique identification. The core data is convert any object or data into a unique integer value known as hash code. Efficient lookups. This unique code acts as a fingerprint, making it incredibly fast to search for and retrieve specific data. The hash code is a unique integer generated for objects. Identifying them during operations like hashing in collections such as hash map, hash set, or hash table, it is derived by invoking the hash code method of the object class which all Java objects inherit. Default implementation. The implementation of hash code in the object class generates a hash code based on the object's memory address. Override. When a class overrides the equals method, it is recommended to also override the hash code method to ensure consistent behavior in hash-based collections. Contract of hash code consistency. Hash code. An object should remain the same as long as the object does not change. Equality and hash code. If two objects are equal, they must have the same hash code. Unequal objects. Objects that are not equal can still have the same hash code, though this is rare and referred to as collision. Usage in hash-based collections. Hash-based collections like hashmap and hashset use the hashcode method to determine the bucket location where an object should be stored. Custom hashcode. The custom hashcode should distribute objects evenly to reduce collisions. A common approach involves combining values of significant fields using a prime multiplier. Common utilities. The object.hash method simplifies creating hashcode. Importance of hash code: efficient data structure, speed and performance, data integrity. Efficient data structure. Hash code is central to creating efficient hash tables, which are widely used in various applications from databases to coaching catching systems. Speed and performance. Hash tables allow for constant time lookups and insertions, making them a critical component for performance critical applications. Data integrity. Hash code plays a crucial role in ensuring the integrity of data structures by guaranteeing the uniqueness of entries. How hash code works. Input data has function unique integer. Input data starts with any data, whether it's a string, an object, or a numerical value. Hash function. The hash function processes this data and applies series of mathematical operations. Unique integer. The result of hash function is unique and has a hash code. Hash code method in Java. Built-in method overriding behavior object state. Built-in method. Java provides the hash code method which is automatically implemented for all objects. Overriding behavior. You can override the default hash code method in your custom classes to define a specific hash code generation logic. Objects state. A good hash code should be based on the object state and should remain consistent across invocations for the same object. Characteristics of a good hash code. uniform distribution, consistency, low collision rate. These are the three characteristics of good hash code. Uniform distribution. The hash code should be distribute the data evenly across the hash table to avoid clustering. Consistency. The hash code should remain the same for the same object across multiple invocations, maintaining data integrity. Low collision rate. A good hash code minimizes the chances of two or more generating hash code collisions, reducing collision handling in hash code. Collision occurs when two different objects generate the same hash code. Separating chaining resolves collision by storing multiple entries with the same hash code in a linked list. Open addressing finds an alternative slot in the hash table. Implementing hash code in custom classes. Override hash code, include relevant fields, ensure consistency with equals, test thoroughly. Override hash code. Override the hash code method in your custom class to define your own hash code generation logic. Include relevant fields. Base the hash code on the fields that define the object's uniqueness and state. Ensure consistency with equals. If two objects are considered equal by the equals method, their hash codes must be the same. Test thoroughly. Write unit tests to ensure your hash code implementation produces consistent and accurate results. Best practices for hash code implementation. Use prime numbers. Combine fields carefully. Avoid complex logic. Consider immutability. Use prime numbers. Employ prime numbers in your hash code calculations to improve the distribution of hash codes across the hash table. Combine fields carefully. Combine multiple fields in your hash code calculation to ensure a more robust and unique hash code. Avoid complex logic. Keep the hash code calculation as simple and efficient as possible to optimize performance. Consider immutability. Immutable objects make hash code generation state never changes, simplifying consistency. Conclusion and key takeaways. Efficient data structures, understanding hash code, best practices. Efficient data structures. Hash tables powered by hash codes are core component of many efficient data structures crucial for performance optimization. Understanding hash code. Understanding the principles of hash code is vital for developing effective and reliable data structures in Java. Best practices. Adhering to be best practices for hash code implementation, ensuring reliable and performance in Java. The hashcode method in Java plays a critical role in optimizing the performance of hash-based collections like HashMap, HashSet, and HashTable. By providing a numerical representation of an object, it helps efficiently store and retrieve objects in hash-based data structures. To ensure correct behavior in such collections, it is essential to maintain consistency between the hash code and equals methods when overridden. As well designed hashcode implementation minimizes collisions, improving performance and ensuring correctness. Key takeaways are purpose, contract, default behavior, overriding, best practices, usage in hash based collections, performance considerations. In purpose, a hashcode method generates a hashcode for an object. Contract. If two objects are equal, they must have the same hashcode. Default behavior. The default implementation of hashcode in the object class is based on the memory address of the object. Overriding. Use efficient algorithms, prime numbers, and combining to reduce collisions. Best practices ensures the immutable fields primarily influence the hashcode. Usage in hash-based collections. Efficient storage and retrieval in collections like hashmap and hashset. By performance considerations, well-distributed hash code minimizes collisions, leading to faster put and get operations in hash-based collections. By following these principles, developers can ensure the effective use of hash codes, leading to better performing and correctly functioning Java programs. Thank you. Please like, share, and subscribe.